So when we have a fraction, and I'm getting you to write all of these decimals down, when we have a fraction, you can find out what the decimal is with your calculator. So if I go to my calculator and I write 1 divided by 2, that's the fraction 1/2. If I push enter, it tells me it's 0.5. If I do 3 divided by 4, it tells me it's 0.75. So I want you to just, I've done all of these ones already, and I've changed them all to decimals. So I would like you to write them down, what the decimals are for each one of those numbers. And then we have to figure out where these numbers are on the number line. And once you've got all those decimals written down, the next thing we're going to do is we're going to find, some of them are going to be easier than others. Like 0.5, you see on the number line is right here, so I can make a dot there, and above that dot I can write 1/2. Because the 0.5 was right there. Okay? The 0.75. There's no place for 0.75 right now, so I'm going to skip that one for now. Same thing, 0.25, I don't see that listed anywhere. I'm going to skip that now, but negative 0.5, that is right here. I'm going to put that one in green because it was in green.
Can I write it below?
We can write we can write below negative 4/8. That's on the number line right there. Negative 0.5. I've got another one in blue. That's the same dot, right? I'm going to write that one right underneath that. Negative 2/4 and negative 4/8 are exactly the same. Does that make sense to you that they are both equal to negative 0.5? Those two numbers are exactly the same. Negative 0.2, that one we didn't even have to change to a decimal place. That's on my number line, negative 0.2. 4/4 is equal to 1. I have 1 on my number line. That's 4/4 is right there. Okay, but the other ones are numbers that don't show up exactly on my number line. So I'm going to just, I did this one, I did this one, I did this one, I did the 1, and I did those ones. So I've got 0.75. Where do you think I should put that on the number line? Right? Because it's not exactly labeled. I need to put it somewhere. Where do you think you would put 0.75 on that one? We got 0.7 and we got 0.8.
In between?
Right in between there. Yes. So you make a dot right in between there. What number was it originally? And I'll label it as 3/4. Put a check mark. I've done that one. Does that make sense? We could do the same thing with 0.25. We've got 0.2 here, we've got 0.3, 0.25 right there, which was originally 1/4. We can label that point now. Put check mark.
Wait, 1/4?
1/4 is 0.25, that's where it would be. We've got another 0.75, so I'm going to write underneath this one, that same point is also 6/8. And we've got 2 left. Negative 0.875. So negative 0.8 is here. Do you think I should go closer to the negative 0.9 or closer to the negative 0.7 for this one?
7.
Close.
Or in the middle.
It's going to be, because negative, when you're going to the left in your negatives, you see how the numbers are getting bigger as you go to the left? So negative 0.8 and then negative 0.875. What we can do is we can imagine this broken up into 10 parts, and you've got to go 7 parts over. So it's going to be about there. As a fraction, this was 7 over negative 8. That's looking like it's going to be our smallest number now that we put them on our number line. And then finally, 0.3 repeated is 0.33333 continued on forever. Check mark this one. 0.33, I would guess, about there. 1/3. So if we can make a number line, and we can label the points on the number line, now we get a sense of which numbers are bigger and which are smaller. The ones farthest to the left, those are the smallest. Obviously, negative numbers are smaller than positive numbers. And we see that there's a couple of them that are exactly the same. 3 over 4 and 6 over 8. Does it make sense that 3 over 4 is the same as 6 over 8? When we did our adding and subtracting fractions, right, when we multiplied the top by 2 and the bottom by 2, you would get 6 over 8. That makes the same fraction, just looks a little bit different. So if we change things to decimals, that allows us to write things on the number line a little bit easier. Okay. Sometimes I think of money when I'm figuring stuff out. Do you know what that is called? That coin? It's 25 cents, but what do we call the coin?
A quarter.
A quarter. Have you ever heard of it called a quarter before?
Yeah.
Right? This is a quarter as a fraction. A quarter as a fraction, if we type it into our calculator, so I'm going to go to my calculator right now, and I'm going to do 1 divided by 4. I get 0.25. Kind of interesting. How is that related to how much money this is?
There's 25 cents.
It's 25 cents. Why is it a decimal, though, when I write it this way?
Just smaller than 1.
Because it's smaller than 1, right? 25 cents is smaller than $1. So it's a decimal. If you had 3/4, how much money would you have?
Wait,
If you had 3/4, how much money would you have?
no cents.
75 cents. If we go to our calculator, you get 0.75. Let me just double check that. 3 divided by 4 on my calculator. 0.75. Sure enough. So with the quarters, you can think of money when you're figuring out quarters. Now most people, if they know one fraction to a decimal memorized, most people know a half.
0.50?
Yes. 0.5, you can write the extra 0 if you want, or you could just write 0.5. That's a half. The 50 is kind of nice because 1/2 is the same as 2/4. And if you had 2/4, you'd have 50 cents.
What?
What? Now I wasn't going to steal your water bottle. Okay, another review from our first unit. Remember that this is tenths, 2 decimals is hundredths, 3 decimals is thousandths. So you got really good, because I saw this on your test, at converting. Right? In words, we have 1/10. As a decimal, 0.1. As a fraction, 1/10. Next one, hundredths. As a decimal, be decimal 0.1. And as a fraction, 1/100. And I'll give you a head start on the thousands. See if you can fill it in before I put it in. Can you write the decimal and the fraction for the thousands? How did you do? Decimal 0.001 and 1/1000. Equivalent numbers. I think this is part of what makes math tricky, is because one person says, I have $5, and the other person says, no, you have a toonie and 3 loonies. And the other person says, well, I have $5. I said, no, you have 1 toonie and 3 loonies. And they have this argument. Is that not exactly the same thing? Right? So there's often things in math that are exactly the same thing, and it's our job to be able to figure that out. What are all of those ones equal to?
25 over minus
5
They're close, or very close.
minus 1.
-5. Because what is 10? 10 divided by 2 is 5, but a negative divided by a positive is a negative. The square root of 25 is looking for what times what is 25?
5.
That's 5, but there was a minus or a negative in front. It's -5. And 25 divided by a -5, well, 25 divided by 5 is 5. Positive divided by negative is -5. So since all three of those are -5, we would say those numbers are equivalent. Okay? But then you have people arguing because someone says, I have $5, and they're saying, no, you have $2 and 3 loonies, and you're like, oh, that's the same thing, right? But sometimes this catches us when we're doing math. We have to be able to simplify things, because then we can decide what are these the same or not. So, some things that are same. I can write 0.4 this way. I could write 0.40. That's exactly the same as 0.4. I could write 0.400. So I could write 0.4 as 4/10. I could say it's the same as 40/100. And I could say it's the same as 400/1000. And do you know which fraction mathematicians would like the best for this one? Any guesses? For this number, all 6 of those things are exactly the same. What fraction would mathematicians like the best?
0.40.
Those are the decimals. I'm asking for a fraction.
4/10.
4/10. They'd like one even better than 4/10.
40 over 100.
40/100 they like less. They like 4/10 is more simplified than 40/100. 2/5. Can you see that you could take the 4 and the 10 and divide them both by 2? And that would be the simplest form. But 4/10 is super easy to change to a decimal. 2/5 is harder. But I'm going to ask you if you can see the trick and tell me what is 3/5 as a decimal. 0. What? 0.6. Did anybody change this to 6/10 and then go, oh, that's super easy? So sometimes you can take something, if you can change it over 10, then that can make your life easier. Make sense? 0.41 would be 41/100? Because we've done this already before. Okay, There are 3 at the bottom there for you to convert to fractions on your own. I'll put up the answers in a second. Okay, check how you did. Did you get 53 over 100? Did you get negative 6 over 10, which you could reduce to negative 3 over 5? And the last one, negative 912 over 1,000. And what's really cool is with some calculators, and I think if you buy the one through the school, you can do this, but if I go to my calculator now, and I go 912 divided by 1,000, it changes it back to the decimal, but a lot of calculators have a button. For me, it's under my math button. It says change it back to a fraction, and when it changes it back to a fraction, it puts it in lowest terms. So this is equal to negative 114 over 125. Your calculators can do that. You should check if your calculator and how you can do that. If you don't know, show it to me. I'll see if I can figure it out. I think this is super cool. I've showed you a little bit with this before. I'm going to show you the answers, and then I'm going to give you a new one, and you have to see if you figured out the pattern for how these work. Okay? 0.4 repeated as a fraction is 4 over 9. 0.27 as a fraction is 27 over 99. And negative 0.367 repeated is negative 367 over 999. Is this not the next thing in your notes? Did it skip? It skipped some pages, right? Okay. I have to see what happened here. Don't, you can ignore this. We're going to find the pages that it skipped. This is the next one on yours, right? Okay. There we go. I don't know why it skipped that. Which page did it skip to? Oh well. That's weird. Opposite numbers. Opposite numbers are the exact same number, but one is positive, one is negative. That's pretty obvious. But, so what's the opposite of 5? Negative 5. Opposite of 3? Negative 3. Opposite of negative 2? Positive 2. So those are just opposite numbers. Here's more. I'd like you to try these on your own. And then we'll get to our percentages. And then once we get to page 10, then that's where I'm going to get you to work with partners and see what we can do. Okay. Once you've written them down, you can look up in the second one. If you got the right answer but didn't reduce it, that's fine. If you want to write down the reduction, we can do that as well. This is also a bit of review. A percentage is a number over 100. So if you got 62%, it's like if you had a test out of 100 marks, you got 62 out of 100 on your test. And when it's over 100, it becomes a decimal as 0.62. So we could always write a percentage as a decimal. 62% is 0.62. If you got 7% on a test and it was out of 100, how many marks did you get right out of 100? Only 7. That's not your best test, is it? Hopefully not. Actually, it was my best test. All the other ones were worse. And as a decimal, we have to be careful here. It's not 0.7, it's 0.07, because if it's over 100, we always, with the percentage, move things over 2 places. 13.5% would be 13.5 out of 100, 0.135 as a decimal. Five and a quarter percent. These kind of things like 5.25% start to come up when you get older, when you have to borrow money from the bank, and then they give you interest rates like the interest rate is 5.25%. So 5.25, if I change that quarter, remember 25 cents is a quarter, that's the same as 5.25%. As a fraction, that would be 5.25 divided by 100, which as a decimal, move the decimal over 2 places, is 0.525. And 112%, this percentage you actually see every day that you buy something. Because 112%, which is 112 over 100. You did really good on that test. You got all the bonus marks. And as a decimal is 1.12. This is what you pay when you buy something. If something says it costs $10, you actually pay 112% of that. Why? Because there's taxes. Do you know our taxes in Manitoba are 12%? We pay a 5% GST and a 7% PST for 12% total. So you always have to pay 12% extra. Well, not always. Some things don't have taxes. Do you know what things don't have taxes? Foods that are good for you. These, they would have charged you taxes. Junk food, you get charged taxes. But if you would go to a grocery store and buy a banana, and the banana was 75 cents, you get to the place to pay for it, it would still be 75 cents. They're not going to add extra taxes on groceries, which is kind of nice. Some things they only charge one tax on. I think like kids' clothes, you don't have to pay the provincial tax on kids' clothes. But adult clothes, you have to. I have a friend who's an adult, but she's really small, and she goes and buys whatever she has to buy clothes. She still fits into all the kids' clothes, and so she saves taxes because she doesn't have to pay as the rest of us, right? It's not Mr. Shirt.
It's not me.
We're talking about how you don't pay taxes on kids' clothes.
Oh, yes.
Right?
Yes.
So, and I said I have a friend who's an adult, but she's really, really small and still fits in all the kids' clothes.
Could be my wife.
So then you can save money.
Yeah. It's brilliant. Same thing with shoes. It's just got like a size 4 shoe or something.
That's
Size
nice.
4 feet.
I tried it for a while, but it just was really tight fitting.
My
That's not an
height,
image you wanted in your head.
my height would work, but
There you go.
then there's this.
Okay, so what you're going to do for the rest of class is we'll do one together. You can take out your calculator and you can find out, and some of these you might not even need a calculator. 1/4 is 0.25. 1/2 is 0.5. So 1/2 is here and 1/4 is here. I did it on my number line. What are two numbers in between these? I'm just going to highlight them. 0.3 and 0.4 would be two numbers in between 1/4 and 1/2. So if we're able to draw them on the number line, you need to write two rational numbers. And remember, rational numbers are either fractions or decimals that end, and you can write them. Okay, so now there are 1, 2, 3, 4 more questions with writing numbers in between. I'm going to let you do that on your own.